All right, I am gonna get started here. Let's talk about where we're at today. Yeah, last time. Well, so here's the state of our. Let me go back. Um, we are building a Atari 2600 emulator in Rust. The initial goal here is to run a program I made a few years ago. That is basically just an unbeatable tic-tac-toe game. Um, and it doesn't use the capabilities of the machine very well, but it's a good place to start, and I understand the code pretty well. So when it starts up, it's supposed to have a screen that says tic tac toe, and here's the progress we've made so far. Oh, I need to change something, so I need to do tic tac toe dot bin. So that's obviously incorrect, and there's a couple of things happening here. I have some suspicions as to what they are. But we built last time, worked on a stepwise debugger so we could maybe take a look and see what might be going wrong with this program. So that looks like this, and I have like one more modification I want to make to that before we start diving into debugging. I think I know part of the problem. Um, Actually, I have two more quick modifications. I think I know part of the problem. Um, I think the like sort of jumbled writing, I think, is because of the timing of uh, setting things on the TIA, and in our program they're updated instantly. On the actual hardware, there's like a number of counts before they're updated. So it's like um, so we'll have to do a little bit of timing. And I think like once you've started drawing something, like it's locked in until you're done drawing it. I'm pretty sure, but we'll have to look at that. The scrolling thing, I'm not entirely sure about. My guess is that I have just a small error in how much and how long the screen is in probably in the TIA somewhere. I know the program doesn't have VSync problems uh, on other emulators, so I think there might be a couple of things going on there. One is that I have it a little bit wrong, or two, there's some other mechanism that I need to read up on um, that uh, that syncs the program, even if it's like a little bit off in counting exactly how many lines there are. Um, so here's the state of the debugger. I also did some work to make it take a symbol file. So um, DASM actually, yeah, the assembler that is used most commonly for Atari 2600 outputs a symbol file. It is pretty rough. I think I have a potential bug that we'll get to in the debugger when I get there with the disassembly, is that if there's data before there is like data between code blocks, I don't think it'll detect it. I'll just say everything after this point's data. I don't think that's correct. The symbol file does not have enough information to open this up. Does not really have enough information to tell you any of that. So we may have to like use some heuristics, or maybe require people to use a different symbol format. But I think that gets us down a rabbit hole of like maybe updating the assembler, which could be a fun project, but is a bit of a side project. So I'm gonna make it as good as I can for now, and put that on my list of things to potentially do on screen. Um, so what was I gonna say? Uh, yeah, you can see the format here is the name of the symbol, the address, or the number that the symbol refers to, which is usually an address, sometimes not, and then whether this symbol is referenced or not. Some of them are just defined and never referenced in the code. Um, so let's see. Uh, these are interesting. I have multiple things called kernel loop, and it just does this for like local. But it doesn't tell me anything about where code is. I think everything's labeled that is code, like because it has to be jumped to. So I may be able to like use this like all the symbols here that are. I don't know. It's gonna be pretty tough. because a lot of this is, yeah, the heuristics there are going to be pretty tough. So anyway, here's what the debugger looks like. You can see, I think I have it set to break on where I actually need to do the debugging. So after it goes through, yeah, there it goes. I have it break on iKernel. So I can set a breakpoint to either the name of a symbol or the like raw address of a symbol. I have the ability to dump out the disassembly. I think the disassembling thing is interesting problem that we will deal with later, but then I can step through the debugger this way. I can even continue. It'll break on the iKernel every time, but you can see that it's drawing stuff. So we should be able to like have a good look at what's happening here. Oh, and then it's in a different loop, so it never breaks there again. So I'll need to break it someplace different. I have a dog that's being annoying, so I may have to run just for real quick. All right, she's fine. Okay. So the things I want to do today are to add symbols not just to the address, like the labels that we were saying, but I also want to add them to the jumps and stuff. There's an interesting problem there that we'll get to where branching symbols or branching logic is not absolute, so we'll have to like do a little bit of math. I don't think it'll be too hard. And the other thing I want to do is like right as in debug mode, I want to draw something like right at the leading edge of the cathode ray simulated cathode ray beam. So we'll do that. I think that shouldn't be too hard, although that'll mean messing with the renderer. I think we can probably do that. Just like have a mode on the renderer that does that. So let's get in here. And where do we need to do that? So we're in our debugger. Just need to get a little bit of... It's pretty complicated. Eventually, I think a lot of this will need to get... So I think we're just, in the debug loop, we're just sort of like looking up a line and printing it out. So there's no logic here. So I think what we want is when we disassemble, is that right? So this actually, we're asserting key or inserting keys into this symbol. Need to like look up something, I think. Hold on, let me write a to do here. This assumes all blocks are contiguous. This need to get okay, so just get this a little out of my way. Is our value here? It's our instruction value. Try and do. Okay. Here's, I think, where we're formatting our arguments. Using the program editor. So I think it's in our instruction module. Arguments. So I think we'll want to take we don't need a mutable one, but we'll need to take a reference to our symbol map. It says optional. Actually, it's not optional. It'll always be there. It might be empty though. So this will be a reference to a symbol map is a hash map. I want to import that at the top. standard collections hash map. And we should have some errors where, especially where we're calling it. We have an error here. Hash map. Right, we need a hash map with a U16, and that's the lookup for it, and then a string. Is that how that is? We'll find out. Supplied one. Okay, so that's the yes. Takes two arguments. So we're gonna pass reference to self dot symbol file, symbol map. I need to learn how to spell contiguous. US. Mostly just need to learn how to type. Okay, and then in our instruction, sort of formatting instruction. Format argument. So there's a couple places we're going to be looking for this. We're going to be looking for it in absolute, absolute X, absolute Y, absolute indirect, although that's a little funky. I think that's fine. We don't really care about immediate. It is possible for an immediate value to reference a symbol, but it doesn't really matter. Like, it's gonna be hard to figure out whether that's true or not, because we could have a symbol that's pointing to 0. Yeah, in fact, the way we're setting up this hash map might be incorrect as well, because we could have multiple symbols at the same place. But we'll figure that out as we go. Yeah, it turns out that this very old symbol file format is just pretty insufficient for properly disassembling this stuff. So, the one we're worried about, what we'll have to break out here is relative, because that'll be the one where we have to do a little bit of math. The 0-page ones actually kind of matter too, don't they? Because we'll need to look those up in it. Yeah, so that'll be all the. Okay, so let's do the first one. Let's do absolute. So we have an address, and we have formatted our symbol file so that or a symbol map so that it has only the relevant bits, because all the codes mirrored several times. So to look stuff up in the symbol map, we'll need to do. So we're gonna do. If we can get rid of this format, we can do symbol map dot. We'll get our adder, but we're gonna add it with 0x1 f. Should probably be a constant at some point, and then we have an option. So it's gonna say, yeah, you can't do that. So I do think we'll need to, if we get something, we're gonna need to map to. We're gonna need to get an owned version of that, since expected to check string. Let's see. Found U16, so we need to pass this in as a reference to the map. Make that a little nicer. No, we're doing some math on that, so we'll need to do this. Yes, it's fine. What is it saying now? Need to get those error messages a little better, but let's see what it says. Yeah, found an option, right, which is what we expected. So we'll do okay. Unwrap. Or so if we have a string there, we'll just put the string in there. Otherwise, we'll do the same thing. We'll take our probably need an or else, or it'll complain to us, and then we're going to do a format. And this will be much the same throughout. So 4x, and we'll be taking our, yeah. So that should work. Let's see if we see anything that makes sense there. It's gonna be absolute ones. So yeah, you can see we're getting main there. This intim, which is a timer one. So that's for absolute ones, because those are both at absolute places, but we're also needing to store a point two. I think that's, let's take a look at the code there and see what we're expecting. Cowface dude, I do not. Do I have today still on my thing? I have disabled Nightbot. I am because it was stopping everybody from doing things. I need to go back and look at it. But it was stopping people from posting emojis or links and stuff like that. So today I'm actually working on my debugger here. So I have it like pretty much working, and I'm trying to get some. I've got symbols in the labels. Yeah. It's been a while. It's been a while since I streamed, to be honest. I streamed a little bit, or like once last week, and then it was 2 weeks before that. Just the paying job kind of got in the way of the fun job that I have here, which isn't a job really, but okay. So where was that I was looking? Intro. Yeah, so I want this. And that's going to be 0 page, I believe. Let me think. So I made something like this. This will be pretty much exactly the same. Except that I'll need to. So whatever I get here, I'm going to add a story is probably not a good do adder, and then X. I missed a quote. Go. Right, I can actually just do that. Okay. Let's see what's going on here. That should work, and then I'll just copy that. It's going to be Y. It's going to be much the same thing, but I think that I'm... Okay. So then I was thinking, what's next? Relative is its own thing, and then the zero pages are something else completely. That should be... This should be 8 bits. So that should be fairly straightforward. Let's take a look at that symbol file. So like... So that should be pretty straightforward. That should just be looking up the number. Yeah. Some of this is like redefined. I don't love that. We'll figure out what that looks like in a minute. Okay, so our immediate value is not something to worry about. Those can be in the symbol file, but I just like don't want to worry about getting false positives there, and there's no distinction. It's the relative and zero page. So I'm actually just gonna make a like full copy of this. So I need to do something different in each one. So space. Okay, so for relative, we'll have to take this value, and that's actually going to be as a because it can be negative, and then we're going to do. Now, do we have? We don't. We're going to need the current PC. That's annoying. It's a U16. So we'll just fix this and we'll go back and fix the collar. Okay, so just let PC it can be an I16. Is that right? Will that work properly? If I convert to what is it now? That's the question. That iter. So head over to where I'm calling that. That's in the debugger. This is where I'm calling program iter. Program iter. Okay, so that is a bunch of bytes. Okay, so if I do so if I do this as I8 then I've done this before. I can't let me think. Let me remember how to do this. I think I can actually do this. I need to add this to the thing. Will it let me add a U16 and an I8? That's so PC plus I8. It's probably or no, that's plus value. It's probably gonna say so I know the PC. So I think I do this. I think I use this, get this as a U16. If it's no, if it's negative, so I do need this as an I8. Then I can do the conversion here. So value as U16. And then I'll do a wrapping add. Yeah, I've done this before, but it's been a little while. Like this. And then I should be able to just... And I'll do something like this. I don't need to do any more formatting here. I think that just works. And that is not immediate, that is relative. So I need to undo a bunch of this stuff and do it again in the other place. Oh, and I've lost my undo stack. So and my system is crawling to a halt for some reason. Okay. Fix this. I got myself into a real bad state here. Interesting. Okay. So I'm in not immediate. I'm in relative. Right. So I need to do this. Boy, I've just like done it in the wrong spot a bunch of times. Okay. This is I8. Then I need to take my PC. So let adder equals PC wrapping add. So it'll flip over the value as a U16. And that should do all my conversions for me properly. I haven't pulled PC in yet, so that's how far back I went. PC is U16. So that should be right. And then it's just about formatting it in different ways as I go. So, I should be able to do this. I'll need this to be I8 every time. No, zero page is different. Zero page can be... I undid myself into a mess there. Okay, zero page. We actually can do that by just taking this value as a U16. Right, and then for both of these, we will need to do the lookup. Okay, so we take our adder, mask it with our lookup symbol to owned. Yeah, this all looks good. Otherwise, we just do this format. Relative is going to be 2. So we don't need that. We don't need that. I think that's how we get it. So we're going to copy this a bunch. The zero page, this will just work as is. I don't need that part. We'll call this what it is. It's an adder in zero page. So that works fine. And then we're going to do this over and over again. So here's where we sort of messed up our wrapping add stuff. So this is an adder. And what? Just mask it. Or shadow it, sorry. And then this we can just do adder. Like that. And so we should be able to copy this and then just kind of do all these different formatting. So it should be pretty straightforward from here. It's all just going to be the same stuff. Okay, let's see what's still wrong here. I think it's just the debugger. Yeah, so it wants a PC here. So that's, I think we have that available. So that should be... interesting, right? It's not the current PC. I think it's the current byte. I think it's inst.0. Which I'm actually not using anywhere anymore, but we are now. This is the actual byte of let's see, 16. Okay. All right, so we see, I think we've got what we want here. So this is the 0 page. We go here. So we say while we're not on the timer, we're gonna break the X player position, which is wrong. Okay. These symbols are gonna be tough. I may need to come back to those. Yeah, I don't think the symbol file has enough information for us. That's a bummer. We can take a look at the difference between those when it happens. So I'm just going over these. When we start drawing, we should go past this. Sorry, it's taking a little bit longer than I expected. All right, yeah. That's where we sort the next. This might be an immediate value. This should definitely be named. F623 should be named. So that's wrong. F683. Let's take a look at, well, so yeah, we're storing to the right player fields, but we're not. F683. Okay. Right. Okay. So that's because these are 2 bytes each. Man, yeah, that symbol file is like this thing just really doesn't have enough information. Like I'd have to be able to infer. Oh, that these are like somewhere in data declaration that okay, I think this is a can of worms that I am not going to be able to really sort out. This is where I was finding player X pause, but I need a different 9B, and I bet there's another one somewhere, right? Oh, interesting. Hmm. I may actually just feel like I've done something pretty wrong here. My math is wrong. See if I can figure out what it is. Right, so I should have gotten. I see. The relative is wrong. Okay. So what that looks like is this. So in instructions, where we have relative. I think this didn't do the right thing. So let's actually take a look at this. What if I take this as an I-16? Let it run through. Okay, so this is where, if I'm here, I'm looking for it to jump back to, oh yeah, see, that's very wrong. So it jumps back up there, which is, let's debug that value. Should see negative something small. Made this mistake again. PS. Interesting. Yeah, actually, we don't have to go that far to look to see what's happening here. So, that's a good point. Happening a lot. So we'll break at what, like F. It's not where I thought it was. We'll break it clear. Okay. Yeah, so that should be one. Should be something different. So here are the values we got. None of these are negative numbers. So if I take this as a I8, then some of them should be negative numbers. Okay. That's right. Okay. And stuff. Some of them are negative numbers. So then if I take that as an I16, this should still be negative, and then I can take that as still not quite right, but probably a little better, right? I'm guessing this is byte 2, yeah, because that's one byte. This is a second byte here, and so this is byte 2. So it's breaking to byte 2, but it looks like it's 0 page. So we're like missing the piece. Instead of doing this, all right, let's take a look at our. We're doing something similar. So wrapping add args as U16. So we take it as I8. And this gets us the right. It gets us the right behavior. This is just checking whether they're the same page, which we don't need to worry about. So why is this not working? Let's see. Yeah, it's still that. Maybe we need some more debugging here. Yeah, so minus 5. That makes sense. So it's minus 5. This is 1, 2, 3, 4, 5. Yeah, that makes sense that this break is minus 5. Okay, that totally makes sense. W sync is what? It's 2. Okay, so need to look at, let's not do that. Debug our PC, and we'll debug our PC with a wrapping. Let's see, 16. Here we are again. So if we escape here, go look at this. Oh, our program counters are very wrong. That's what's going on. Okay. Right. Right. That was just, I messed that one up pretty bad. So in the debugger, let's see. So we pass this in. We actually need to do. We actually need this. So it's key instead of it's dot 0. It's because it's counting from the beginning of the program. The program is actually located at a slightly different spot. So we do this again. It's a little better. That's the right place. Let's see in our symbol file. 1002 should definitely be lining up with or FF2 lining up with clear, if this is correct. So I'm off by a little bit here. So it is clear. It's on 4. Ooh, so this might be a little bit more. This might be a little bit tougher than I thought. I think I need to offset that by the size of the. Actually, it's not that tough. So basically, I'm not taking into account the size of the instruction I'm doing now. So if I go to instructions, the relative instruction is 2 bytes. So our PC is going to be +2. It's going to be 2 more long. It's 2 bytes wide. Does that make sense? We've already done one. So that does work. Let's see if that continues to seem like it is doing the right thing. I'm a little confused as to why it's... Interesting. Why is Story showing VSync there? Take a look at what VSync is. This is all as expected. Yep. Okay, there's our relative. Yeah, we're not like... We shouldn't be storing v blank. It should be an immediate store, right? Let me take a look at that actual code. Um, storing I kernel. Oh, we are storing v blank, so we're blanking the signal. Turns the display on. Oh, interesting. So that might point us at what's going on with things moving around, right? Because I don't think we have that set up properly. So I need to figure out what happens when the... Okay, well, that's one piece I'll come back to. This is kind of a mess. So the problem is that the symbol file doesn't give us enough information. I read up a little bit about this on Stella. Sorry, the next door neighbors running equipment really loud. And they have like a whole ton of logic to try and figure out what all this stuff means. So I'm gonna leave it as is. It's a little janky, with a big to do that we probably need either to like put a lot of logic in to deal with that, or we need to explore alternative tools to generate these symbol files. Slash maybe even compile the thing, or go and make an update to the DASM tool. Basically, I don't know that I'm super interested in doing a ton of work just dealing with an old symbol file when it might be easier just to figure it out somewhere else. This music's a little loud. Make everybody's life easier in the long run. So I think I'm gonna add this. Dash implement. Let's see. Symbols in code. And I think I'm gonna go to my README file. Let's see. I don't have all this stuff implemented. Don't have IR. Do you have this? There's more TIA stuff to Figure out v blank. So that's, I think, one of our bugs where we have things sort of scrolling around on screen. We have added graphics, which sort of there. We need to fix graphics. Yes, okay. And then the big thing to do is, I think we kind of need this near the top. Here. Oh. This. Put a note here. DASM symbol gives very little information. Look to alternate assemblers, defining DASM, or otherwise putting a symbol file that will tell us things like data segment location, code segment location, info. Trying to think of what else it could do, but like that. Byte declaration info, code segment location, data segment location, differentiates between the same. Same value, etc. That feels like a whole project in and of itself. For now, I'm just going to see if I can debug with what I've got. So it's not too bad. I think what I know about here, and we can take a look at that. This kernel loop. The things we know about here are that this should still be in blanking because we're not actually turning on. That's right. We're not actually turning on the beam until here. I'll need to know. I need to look into how exactly that works. Which I'm a little confused about. I may have a problem that my timer is not set up properly. If that timer is set here. And overscan. So we turn off the image output. And then we set a timer that should last 27 scan lines. So 27 times. So it's 32 times, wait. 27 scan lines times 76 divided by 64, which should be 32. And then we set that timer, and then we wait for, oh, interesting. So I think I might be wrong there, because I'm not setting the timer again. So it should be waiting. Oh, it must be vsync stuff. Okay. Or v blank, what is it? vertical sync. All right, so we're turning on the VSync signal. Okay, I'm going further down into this than I wanted to. Turns the vertical signal on. Then we set a timer. Then we do a couple of VSyncs. This is what's my X? 49. This can be a long time. Why is that? Okay, 49. 41 scan lines. 49 equals 41 times 76 divided by 64. Okay, let's take a look at our Stella documentation here. Where are you getting 46 scan lines from? Because it should be in vertical sync. Okay. 41 scan lines. I see. So we're starting here. We're doing this like vertical sync that has to happen. So that's we're kind of ignoring that right now. That's what I was thinking. That's these three third scan line. We turn off the VSync signal. So that is something we could mess with. But I was thinking I was actually off by okay. So this sets that timer that we see in. I did not want to go into this, so we'll see if it leads me into it. So then it's waiting for that timer. So it shouldn't actually be drawing anything at all. It should still be in VSync. So it should be. Okay, I think we can actually do a little bit to debug this. I think we'll need. Yeah, because it's drawing and it shouldn't be. So we'll need a little bit more information on the TIA, which we can have it print out here. Did I commit everything? Let me do that before I go ahead. Read me. Okay. So in the TIA, we're display for TIA, right? We're putting out a bunch of stuff. So I think what we want, I don't think the combined play fields are very interesting. We'll want to see if, and color clocks are actually not very interesting. So we'll leave the combined play fields for now. That'll show us whether it's reflected or not. What I think I want is current line, current, let's call it column. We'll call it pixel because it's kind of closer to what it is. So this the place where the scan line should be on screen. So that's going to be after self dot current line self dot current pixel. What do I call that scan line? Call this beam position. Spell position right. Spell position right. And then it's going to say that those aren't implemented. So it's going to say no method. Specifier message. argument never, I didn't mess with that. So I have background color, playfield color, current line, beam position, color clocks. Oh, I got rid of color clocks, yeah, because that's not super interesting. Okay. And then I need to do impl PIA. Just get some. Oh, I have. So this is not quite right, but I can kind of reuse both of these. So I have current row. Oh, and these take other functions. So yeah, these are completely different. So this is self. Don't need immutable self. We'll just take a reference to self and we'll return. And we'll turn to U size. That's actually just going to be self dot color clocks and divided by color clocks per line. And then the current on this line. And that's just the mod. That's just what's left over. So then when we break on ikernel, before we bust everything up, let's make sure that it won't. Beam position. Yeah, let's get rid of this current stuff anyway. Call this scan line and beam position, which is pretty much what we want here. So for display, scan line, beam position. Cool. So this will go through and it'll break on our kernel. We can actually make this run, I think, significantly faster to our breakpoint, but it's not that far anyway. So then we can take a look at our TIA, and it should be saying where we are. So it's saying our current line is 37. So that's probably our problem, right? And our beam position is 112 or 117. Which is also interesting because I think we just. So I think we have something wrong with our math, but let's take a look as we move through. So we stored a wsync. So you see the timer still has 44. Huh, interesting. Okay. So it might be worth throwing something in overscan, although we shouldn't, or in vsync to see where we are. I think we're like not syncing up the screen. I think that's part of the problem there. Okay. I need to, okay, so I'll need to go look at the, yeah, we're just kind of starting wherever so we're saying that the thing's drawing, and we aren't ever syncing up with our. We're doing a bunch of initialization and stuff, and the first time we go into vertical sync, we're not ever syncing up with things. So I do need to look into how that works because we happen to be like already at line 38 by the time we're here. So that's why it's drawing a bunch of blank stuff. Right, and you can see, so some of this is working, right? Like when we break the ikernel, we jump that far ahead and we like wsync, and then the next thing is, and you can see it drawing in over here. Okay, so let's take a look at our documentation for VSync. There's like a whole section in this book. Oh, fun thing. Somebody made the book on Lulu. So you can actually like flip through it and read it, which is really cool. It was just a few bucks and it's pretty short, just that. But this is a guy named Steve Wright wrote this. There were no guides. He basically just wrote up a doc about how this thing worked so that people could make games. So that's pretty cool. So let's go back here. Yeah, we can quit out of this. So where do we want to be in here? Synchronization, vertical timing, horizontal timing. So that's page 18. That's a little bit down here. That's page 13. Page 18. Horizontal timing. Hardware counter of this chip produces all horizontal timing, such as sync, blank, burst, independent of the microprocessor. That's okay. So we're doing that correctly. This counter is driven from external blah 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 isolator, and has a total count of 228. Blank is decoded as 68 counts, and sync and color burst has 16 counts. Interesting. I don't know about that color burst, but that's sort of an interesting idea. Vertical. One bit of sync and vertical blank. The timing of these functions is established by the microprocessor writing 0 to 1 of these bits. Vertical sync. Let's take a look at more into that. Because I think horizontal bind together to produce composite sync. The composite sync signal drive. So I think what this is saying, which is something I wasn't super aware of, is that actually writing that vertical sync like tells I think, and this makes sense based on how I understand old TVs, and is that like it allows the programmer to send a signal that syncs the screen on every round. So if you go over, you'll have problems because it won't work. But if you go under and you hit this vertical sync, I think it'll just get you to the top. That's interesting though, because it's like, can it mess with the timing? I don't know. This is a little bit beyond my knowledge, but this is what we're here to learn. Let's see. I was hoping there'd be more on it than that. Not full screen. Sync. V sync. Hopefully it'll vertical sync timing by television protocol. This is probably what I want. For the person, it's 262 horizontal lines, and each line is divided into 228 clock counts. Yeah. A typical frame will consist of 3 vertical sync lines, which is fine. 37 vertical blank lines. Atari's research has shown that this pattern will work on all types of TV sets. Each scan line starts with blah 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 blah. Okay, all horizontal timing is taken care of by hardware, but the microprocessor must manually control the vertical timing signal to start the next frame. The last line of the previous frame is detected. The microprocessor must generate 3 lines of VSync, 37 lines of vertical blank, and interesting. Okay, so if I'm understanding this correctly, when the see if there's any more information about it. Yeah, it's talking about how you can use. That's what we learned before. Interesting. I'm curious if the so this is fun stuff. Sorry, I should talk about it. There is a gentleman on YouTube. His name is Ben Eater, who talks about electronics, and his stuff is really interesting. And one of the things he does is a VGA board, essentially with 6502 computer he built himself. It's it's really janky, but it's really interesting. Um, and uh, the the kind of fun thing about it is he goes it has him go into detail about like how all this stuff works, because the VGA like protocol is very similar to the like one in the TV. So the thing that I'm thinking here is that what I was wondering is if the TIA had any safeguards that would prevent you from doing bad things. Because if you use VGA on a CRT and you don't turn off the beam like while you're doing these like synchronization things, vertical and horizontal, and the beam is moving from one place to another on the screen, it can actually do like damage. It can seriously damage your monitor. So like you're trusting your VGA drivers to not break your monitor, which is crazy to me, or your monitor to have some safeguards. What I'm wondering is like, I think the same thing holds true for televisions, and this TIA is like controlling the television pretty directly, and I'm like wondering if it has safeguards, like if you don't blank, and you sync, because that's what moves the beam. If you don't blank but you sync, um, will it like automatically turn it off so you don't break people's TVs? Could Ataris break people's TVs? That is an interesting question. I won't look it up on stream, but that is something to think about. So basically, I missed a little piece of this TIA logic. That should be pretty straightforward. So like I am. So if I do, let's see, if I look at my current buffers and I look at tic-tac-toe DASM, and then I look at this. So this is the VSync signal. Um, Load 2. I'm loading this into X. I'm setting a timer. Where am I storing A into VSync? Okay, right. So I'm storing A here. And so that should reset the thing. The scan lines. Okay. Some of this timing might be a little funky, but then like we're doing 1, 2, 3 lines and we're turning on the VC sync signal off. We don't really have to worry about that. Um, but that should cue us, I think, to reset our color clocks as soon as that's set. The thing is, we need to do it after the clocks are counted for the television. So it's going to be similar to WSync, how we did WSync here. Yeah, so we even accounted for VSync. We just didn't do anything with it. So when we're saying self.wsync equals true, well, oh, interesting. We are doing it. So if we print it out, we can actually take a look at what's happening. Um, that's actually pretty important. So we'll do a new line, and we'll do v sync and v blank. Okay. So it's saying I don't have those, but I can take a look at them. So after beam position self vsync and v blank. I'll probably need to take into account v blank at some point because it does. Right, these are just going to be bool values. That's fine, because it does turn the beam on and off. So, like, if somebody forgot to turn their, like, I'm sure somebody has messed with that. Pretty much every function on this thing has been kind of hacked in some way. So, let's take a look at our. So when it starts drawing, we should see vsync and vblank start to do things. Okay. Yeah, and it ended. It went pretty quickly, but that's fine. We can take a closer look at it, but that should tell us to restart. So the thing is that we don't know. Hey, how's it going? I'm doing good. How are you? I'm have you been around to see this sort of mess that I have? Let's see. I changed how it works, so I need bad. Yeah, yeah, that's so that's supposed to say tic tac toe. We're working on the reason it's scrolling, which I just figured out. Is because I'm not taking into account vertical syncing, and then last time I did this sort of stepwise debugger, which definitely needs some work. And I've been working on that a little bit today, but it breaks on a breakpoint, and you can like sort of step through, continue, that kind of stuff, and sort of see the state. I'm just printing out the state of all these things. So, um, yeah. So what I was working on, Bear, was I was just about to sort of implement the vertical sync handling because I sort of ignored it, and basically like the frame was happening like at just a random time, basically. Like wherever the TIA started started counting at the beginning of the program, which doesn't like mean anything, and it's actually like on the programmer to send a signal to like reset the frame. I'm like it brings up all sorts of questions to me about like how like if a Atari program could have broken an old CRT television, because like some of the stuff that you have to do, like turning off the beam, like before you do VSync, like on those old CRT televisions, you could do damage if you didn't do it right. And I'm like, what? Were there any safeguards, or could like some jerk who didn't know how to program an Atari game like ship something that would just break your base televisions? Um, and at some point, I'm gonna go look that up, but it raises a lot of questions. So anyway, so programs do 3 lines of v blank, and so I was gonna do. Yeah, yeah. I feel like they must have put safeguards in it, but like if you're driving VGA, like directly, if you're building a VGA driver like on an old CRT monitor, like you can easily like ruin people's screens. So you have to trust whoever wrote the driver that they're like not doing something like moving the beam around while it's on, because you could like really like you could just destroy monitors. So um, I'm hoping. I don't know. It was sort of the Wild West back then, so who knows? Um, let's see. So yeah, so basically, I think what I can do is I can always just check if after the instruction is run to see if the vertical blank is true. Yes, let's take a look at this. I don't think I need any special handling, but let's see. So there's 3 lines of vertical blank, and then it'll get turned off. I'm trying to decide if I can just like or vertical sync. I'm sorry. Um, and in the program, we're kind of doing that in like a. So we turn that on. We turn it off at the very beginning of the line. But that's already 3 color clocks gone by. Oh, interesting. I think I'm gonna like mess some. I'm gonna have to figure out how to like. They're always kind of syncing. So I think I can do something if. I'm gonna have to go take some time outside stream to do this, but I think I can implement something now. So, let's see. So I think. So we're gonna tick those ticks, but then we need to like reset the clock in certain cases, if it's W sync, the color clock, so that we know that it's gonna be. I think this looks like this. If this probably be done internally to the. Yeah, this probably should be done internally to the TI, but let's see if we can get it working now. Uh, hmm. Actually, let's do it in a function so we know. Let's see, we can do this too. If self.2, then we're gonna tick some stuff that this has to know about ticking. So what can we do? We can do like just call this like sync. Then all that state's internal. So I think we should be able to let's implement a function in here. It's default set get tick. wsync ticks, there's a bunch of stuff here. Okay, I'm reading about this, but if you place it could definitely happen. Yeah, yeah. Other common issue is improperly adjusting. So you'd see that's a user error. Oh, okay. Okay. Yeah. No, I had. It seems to be an old wives' tale that persists because some pretty smart people still talk about that. That's interesting. Power on, power off for magnetron. Okay, so the cathode ray tube can't break things if you sync it with like the beam still on. That would make sense. That would be a sensible way to like build TVs and hardware and stuff. It's just interesting. There's this guy Ben Eater who talks about VGA, and he like is a pretty smart dude, and he still talks about it. But I would believe that it's just a pretty persistent sort of old wives' tale. Like it's a thing that like could make sense, but was just probably never really a thing. I believe that that's one of those sort of too convenient just so stories that has persisted. Um, Mute. Yeah. I was there for the 80s too. I only remember the last part of the 80s. Um, but this doesn't need to return anything. This just does some stuff based on internal sync. So we know that when wsync happens, if self.vsync, we're always gonna pretend it's the last. Yeah, yeah, yeah. I started with the Nintendo. There were, yeah, there's some persistent old wives' tales about the Nintendo as well, right? Like there's the I still know people who blow in the cartridges and think that that has any effect, other than just sort of like rusting out their contacts over time. So, um, yeah, like 40-year old adults who just like really believe that like blowing their moist breath into the cartridge is gonna do some good. So, okay, so I'm here. VSync. Yeah. Yeah, I can't remember. No, I do remember something about the design. Yeah, that's a slow process. Yeah, the design of the Nintendo was actually the reason behind a lot of the problems it had, like making contact. And it's like I saw somebody like break one open and show like how things get like bent on it and stuff, and like that whole mechanism. Uh, it's just kind of wild. I like a interesting design choice that I don't fully understand. I think it maybe because like they wanted it to be like a VCR or something. Like they wanted you to be like they didn't want you to have to stick something in the top. But this is just vague memory. Um, but the top loading just works, and it like every other system ever has used it. So um, all right. So basically, what I'm going to do is I'm assuming I'm at the end of my vertical sync every time I do this. So I'm going to be and then it'll happen over and over again until it gets turned off. Um, but so basically going to be assume that we're like zoom in. I'm gonna assume that we're down here. Actually, whoop. I'm gonna assume that we're starting. Yeah, right, right. Yeah, and I think I don't know. It's been a long time. Um, yeah, I think there was like some worry about American markets, and they're like not wanting. I think after the first video game crash, and they're not wanting to seem game like. Yeah. Um, Okay, so I'm just gonna assume that we're starting right here after the three lines of vertical sync and right at the beginning. So we've just done our W sync, which is the horizontal sync, um, and so we're just gonna set our color clocks to 228 times three. Um, yeah, yeah. It was a cool system, man. I remember that was the first one I had, so I remember being really excited. Um, Bringing that home. People like I talk about it the same way that like people talk about when they brought their Commodore 64 home or whatever. But like, yeah, um, my parents, my parents really weren't on board with the video game thing. So like that was like I had did chores for a year to be able to afford that thing. So yeah, and the games were like wildly expensive for the time. Any good games were like $60, and yeah. Um, I guess because the cartridges were expensive or whatever. It's funny that the game, like, the most expensive game I ever bought was Final Fantasy 3 on the Super Nintendo, and it was like $90, and in 1992 money or whatever, it was. Yeah, yeah, it's because it had save games and all sorts of like extra stuff. Yeah, those cartridges were wildly expensive. Um, cool. Yeah, so I'm. This is. Oh yeah, yeah. We had a rental store called Visart Video, and they like rented out games like they rented out videos at the time, which is like overnight. So, so like you got like we would go early in the morning and get a game, and like you had to like take it back the next day. And so it's like it took a while before they caught on, even with videos too, where like you could do like multiple day rentals, and yeah, you would like eventually rent games for like a week. So we're gonna do this is some times three. Not pretty. It might cause some problems. Yeah. Yeah, eventually Blockbuster took over like all of them. Oh, nice. Yeah. Oh, yeah. I remember when they started doing that at Blockbuster too. The other one, the one we went to normally, it didn't have that. But like, yeah, they had them in like crazy like theft prevention like boxes, I guess, that you could like hook up things. Yeah, it was. Yeah, it was a cool, it's an interesting time. Yeah, I don't know if anybody will let you rent a. Yeah, I don't know if anybody will let you rent a PS5. I don't think it works that way anymore. Okay, so let's see what that looks like when I run that. I'll start break on the iKernel, but I should be in a different. Oh, that's very wrong. What's happening there? Well, that's really interesting. I broke something good there. It didn't fix anything. What am I waiting for? I'm waiting for a timer. Oh man, I really messed something up. Okay, so how did that mess something up that bad? Yeah, don't know. Hmm. So actually I can take a look in vertical sync. So I should be. So this should set my VSync to true. Yeah, I'm really curious why it started drawing stuff. Um, Maybe I did something wrong. I mean, I did. I clearly did something wrong. All right, so I should be at, yeah. So I'm showing that like I'm at line 3, and then I WSync for the last time. So I should be setting my line. Oh, right, no, line 3. Yeah, that all makes sense. Yeah, so now I'm before my I should be drawing, which makes sense. And then at like 41, I should be, but my timer's all off. So I've like messed up my timer somehow. Um, which is interesting. How would that happen? My timer doesn't have anything to do with that. It's a little finicky, so I may just be like doing something that sync. Everything is sync. So, hmm. Yeah, I think let me make sure that that is what's breaking things. I need to figure out why sometimes things hang on to that process because I have to kill them manually with. Okay. I may have gotten myself into a bigger mess than I thought I would here, but that's fine. So what's my timer? Yeah, so my timer rolls over. Interesting. Wait, this is my. Yeah, so something else I changed broke. So not this part, but something else. Let's see what's different. Okay. Okay, so that it does work. So if I get stash up. I mean, it works. And let's look at my diff. So, but I've commented out that. So this should still work, unless something is really strange. Just adding code broke my... Like, nothing's even being run. That is so strange. Cargo clean. Is it something blocking? No, I don't think so. I do have a problem with occasionally if I'm like if Rust Analyzer or Clippy or something, like if I try and run something too fast, it'll hang forever. And then I have to kill it because what's it called? Escaping me. The terminal interface library is like putting it in raw mode and like, but it's not listening yet. So I can't control C it. So I have to go kill it on a different process. But I don't think that's what's going on here. Right, not clean. So I cleaned it, so it's gonna take a second. No, it seemed like something like I added code that I didn't even run and it changed the behavior of the thing, which is like kind of wild. It means that something I have is like sensitive in a way that it shouldn't be. I don't know what UB stands for. I hate when I don't know what things stand for. Like I should probably undefined behavior. Yes, okay, that makes sense. Yeah. Uh, it's not though. It's not fun. Yeah, yeah. That appears to be something that happened. Um, because I added this, but it doesn't do anything. No, maybe it did do something. Maybe something has like a... Right, this is exactly what was happening before. Wait, no, it's not. That's why it broke. Okay, so I was like, I'm gonna make this function do everything that needs to happen, and then I didn't make it do everything that needs to happen. It's not undefined. My behavior is undefined. That's what's undefined. Um, dot TIA dot sync, and we'll actually have it do kind of all of this. I just want to make sure that this works a little bit. Yeah, acronyms get me. Emoji that I don't understand, I'll spend 30 minutes like trying to like determine the exact facial expression of like a little yellow emoji and be like, what do they mean by that? Like what is this emoji meant to portray? I just like, okay. Well, that's a huge win. All right. So that was basically the problem. The problem is that I wasn't doing that I wasn't properly doing VSync. So I was starting my drawing. I started my drawing somewhere in the middle of the screen because I was just at a random place. And then I'm guessing that probably the reason it was scrolling is because uh my code is not precisely the right number of scan lines long. Um I'm a little bit surprised that it's starting like right at the top. Maybe I'm not. I don't know. We can look into that a little bit later, but that is a fix. So I'm gonna move some stuff around here. So self dot. Yeah. We'll have this thing just do all the syncing stuff. And it'll return. So here's the thing. I want to be able to tick based on the response of this. If I tick 0, it should be fine. So should be able to do self dot tick. Tell it to sync. Just slowly start moving this stuff out of here. So it's like if self dot wsync, it's going to return shit. Syncs. It syncs the PIA and returns a number of ticks to advance the clock used for the wsync signal. I don't know if I love this pattern where I'm having things like kind of just return numbers that are like unnamed. I'm doing that a fair amount in this, but I think it's okay. So then get rid of that. And then that's not a bad idea. It's actually a good idea. Then do you have to like? That's actually a really good idea. Then you have to implement deref for them or like use it with a dot zero all the time. I don't remember my new type pattern very well, or if they've done anything to like make it more ergonomic. But I think that's a really good idea. If you tuple struct yes, you'll need a dot zero. Okay. But like if I did, I will just say you can do a standard struct and have it field all the same though. Yeah, that's actually not a bad idea either. That might be better. Like it's a really nice thing to be like, yeah, like struct. So we're talking about like new type pattern, which is like the you can be like struct like my thing. Like say it returns a U8 or something like that. The way to like if you get one of these, the way to access it is with like thing, not this is obviously dot zero, which is like this is nice and succinct, but it's not the best. But you can sort of do a similar thing, what Bear's talking about, and like have it like name something and then like a value U8 or something like that. Right. Yeah, right. Yeah, or impl and get a get method on it, which is also a nice pattern. Yeah, let me think about that. I think that's probably the way I'll go in general with this thing because there's a lot of times where I want to return a value out of something to like have some effect higher up, um, and they're not named most of the time. So having some kind of name or something meaningful, yeah, I think those three are kind of so. If return 0 and then is false, and we want to return uh, self dot wsync. And we want to do this. Oh, we can't return it. Okay. Yeah, I think that's right, Bear. Is wsync ticks self dot color clocks? Oh boy, that makes things interesting because I have to return it and then like I have to set my color clocks and then return. Oh boy. Well, that's not the worst thing. So I get let ticks. So get it, then update it, then return. It's a little ugly, but should be fine. Then this doesn't need to be, this can just be a private function. What is it not like here? Cannot borrow self.tia. Oh, because it has to be mutable, and it's probably, I need better error messages, but let's see what it's saying there. Yeah, second mutable borrow occurs here. Try adding a local storing the argument, and then okay. Yeah. I find this annoying because I think it should be able to. I think the compiler should be able to do this, but there's probably some reason that it can't. But like I should be able to put this in line and have it know that I'm like giving back control of the thing, because it's a mutable reference to self. I guess it's like I'm getting a mutable reference to TIA and then I'm using that. I don't know. I feel like I should be able to do that, but that's fine. Cool. So let's look at that. I've got a stable image. It's a junk image, but it is stable. So that feels like it feels like a little bit of a win so far. So let's take a look at what we've changed. Okay. Got these things for better debugging. Cool. That was not the problem I actually expected to fix today, but that is cool that was pretty straightforward. Fix. So let's see. Handle basic signal to prevent unwanted scrolling. Actually, let's say this is my commit and then say this is unwanted Scrolling. And then I'm gonna just think about that new type function. So let's see. Or that struct. Am I like returning? Some of these like make sense for. So let's say like. WSync. Wait a sec. Clocks. Regular struct probably works fine though. To speak sooner, like, yeah. I think that's. Yeah. So it'll be like. So then, just to try it out. Let's just do default for the return value here. Oh, I didn't derive default. Say, let's be explicit about it. Something so I'm not like racking my brain later about why I did it this way or like what any of this means. I think that would be clocks. That's not quite right. WSync. Private. I'll just nice. Beautiful. Okay. I think that is a good. I think I'll just keep that in there as a pattern and think about it as I go forward. Whenever I'm returning just sort of bare values that are like sort of tangential to the function itself. Um, okay, so the next problem is what's actually happening. Um, what's actually happening on that screen that is pretty wrong. So let's supposed to say tic-tac-toe. It does not. So let's see. Vertical sync is probably not where we want to do that. I think we want to break on like I kernel loop. Okay, and here we are, and we started drawing, right? Interesting. We got what's an x? X is the value C0. I think that's just a countdown value. And this is like a thing. Okay. Oh, you guys can't see that. So let me put it back on screen. So it's unfortunately not named, but this is we're storing this in playfield 0. You can see we're on current line. So that is 0. We're storing this in playfield 1, which I think is a little bit of the T. And we're storing this in playfield 2. You can see it starting to draw there. I think I want to go back at some point. We'll see how well I can debug here. I think I want to put like a little indicator of where the beam is, because basically it's like drawing. It's drawn once, maybe twice across this line. I'd have to look at the program to see, but this seems about right. And then it started to draw over here, and you can't really see it, but it's drawing white. So you can see that the playfield, it should be 2 white bits, or 4 white bits, which are times 4. So it's like 16. Each of these is like 4 wide. And then a space of 12, and then 12 more. So I think that's for the eye, but I'll have to look. And then, so you can see that we're at beam position 99, which doesn't put us quite halfway through, but we're about to start. No, this should. Okay. So I'm loading A with the next bit. So that's going to be playfield 0. So it's. I may have to go look at the actual sort of files for this. See if this, because I feel like I just may be loading the wrong stuff in here. Because this is reflected. So here's the full one, or it's not reflected. So it should start drawing this. Okay, this what I'm looking at does not make any sense to me yet, but that's a line. Hmm. It does not look like a T. I think I maybe. I mean, of course, it doesn't yet, but okay. So let's go take a look at that. Tic-tac-toe, source. So I think I don't have DASM here. So I think I may need to run. I think I can. What's my Ruby version? Okay. Ruby. When I built this, I built a little tool in Ruby for turning images into binary. So I should be able to go into tic-tac-toe and like take a look at that Ruby file. So Ben. So I have a make file that I think does everything that it needs to. Okay. So I think it'll break when I try and use DASM. So that's fine though. It should make everything else. So if I just make, okay. So then I can see tic-tac-toe dot BMP. So for that first line, I should be getting the first strip of each of these. So strip underscore. I should be getting. A little confused as to why I'm getting what I'm getting when I do that. Yeah, it should be padded out by a lot of zeros. I feel like I might be just getting kind of random garbage. Um, so that looks like, let's see. Okay. Okay, so I should be getting it offset by y. So let's take a look at what y is when I do that. Okay. So what? So we're doing a bunch of things. These are basically multiplying this thing by 4. So it transfers whatever x is to the accumulator, which is, and multiplies that by 4. And then it transfers whatever's an a into y. So then that, and so then this gets, I believe everything is upside down. Maybe that's my issue. Um, yeah, I think everything's upside down. So when I get from this address with an offset of y, I feel like I might have a bug in my offsetting logic, which is interesting. Then I'm getting 0. Um, but when I get with an offset of y here, I'm getting not. Hmm. And this should be getting the. Okay. Yeah, interesting. Okay. So I think I might have a bug in my uh load A absolute with Y indexing because I think if I'm reading this correctly, yeah. So this is all upside down. So that's one thing. But so let's see. The strip 2 is where we're getting something I'm not expecting. If I go to the bottom of that, yeah, I shouldn't be getting any values in there for like 4 bytes. And I should be offsetting. It's like 2A or something like that. Okay, so let's take a look and see if we can. I think I'm storing the playfields right because they're showing up where I'm expecting. So I think it's load A with a, yeah, absolute with Y. So let's walk through this and see what might be happening. Okay, so we're getting our low byte, we're getting our high byte. So it's adding whatever the Y is to our address, which I think is exactly what's supposed to happen. But let's make sure that it's not. The one thing I can think of is that Y might be. So that's this one. I think it's got to be positive, right? Let's let's do a little bit. See if this makes any sense at all. So X is set to C0, which is there. Then left shift right should multiply C, divide it by 2. Does that make sense? 2A, C0. I think so. Might want to check my math there. So my offset is 2A into this first strip. Let's see if that makes sense. 2A is 32 plus 10, so 42. I think that makes sense, actually. Okay, so that's not it. I don't think. Let's see. So if I offset 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's go. 42 down. Am I right about what? Is 16 times 2 plus 10. So that should be 42. Interesting. Let's take a look at this math one more time. So we're loading X with a 192. Oh. 192. So what is 16 times 11 would be B, 12, it's 192. Okay. Yeah, so it's almost like I have extra bytes here. But that's all the math is correct. So I just sort of probably wrote this bad in the first place a long time ago, but that math is correct. So the so then what I'm getting. Oh, interesting. So I am getting stuff at the top. I feel like it might be doing something when it loads it in. Here, come on. There's some scan lines. Um, okay. Let's see. So that still shouldn't break everything. It looks like I probably just did my math wrong or something, but it should be fine. There. So byte 60. I think these are. Oh man. Let me switch the music. This is getting. This is like Final Fantasy music, but some of it is not good. Um, like Final Fantasy music's great, but it for some definition of works, yeah. Nomad Pixel. Today we fixed the bug where it was like scrolling around. That was just I wasn't taking into account the vertical sync signal. Um, Aside from the actual physical test cart run, a couple. Yeah, there are a bunch out there. Pretty handy in diagnosing what I screwed. I don't know how featureful they are. There are a bunch of ROMs though, where people are like test very specific uh like issues basically. Because there's like just a lot of idiosyncrasies about how the Atari works. So and you can like there's stuff that wasn't often used, but like there'd be one game that's broken if you don't do it like exactly right. So I think that will be my next step. Is like looking into to implementing some of those and making sure that I have all of my logic right. Um, as far as pass, we're lucky enough to have some diagnosing. Yeah, yeah. I think those will be pretty key in like making sure that my thing actually works because I'm not using like half of the features of the system in this particular program. Um. Oh, I'm doing this -1. That's really weird. Why am I doing that? Uh, okay. So then I guess what I'd be expecting. 42 down. So so we can probably test this out. I think I'd be expecting a 3 in that second in playfield 2 on the first go round 3 and then a bunch of zeros in it after that. Um so we can at least like see if we're doing something just very wrong. I need to make this go faster. I will do that after this, after it gets to where we need it to go. Okay, cool. So, this one should be 0. That's fine. This should be, that should be 3. Huh. Oh, okay. Playfield 1. Yeah, that's 3. So then playfield 2 should be something different, but that's fine. I just want to make sure that it looks like it's doing the right stuff there. So it breaks. A is in the Oh, interesting. It should have decremented by, yeah. Okay, that's the right number there. I wonder why it skipped over my. I wonder if it's doing the division by four properly because it skipped over my second shift right there. So anyway, I should have three again in playfield one. I don't. So I'm like past that. So if I continue and then I go here, so I'm very much in the wrong place. So that's kind of what's going on. Which might be a bit of a pain to debug on stream. But I do think I have an interesting issue, and it looks like my program counter is off on my LSR, which may be actually causing a bunch of problems, right? So if I'm here, my program counter is at FO8B. LSR is 1 byte, so it should be at FO, and this my program counter is like way up here. Um, Next, it should be at FO8C, and it's at FO8D. Well, that's a bug. Okay. So we're finding stuff. That's good. This I do have a feeling I'm gonna find some of these LSR. As I sort of wrote these without no, it is 2 bytes wide. No. No. Uh, what did I do here? I just copied E. Oh no. Okay. Um oh, and then I wanted to get in my debugger here. And I wanted to. Well, that makes sense. This is everything being broken here. My wait time millions. I'm gonna wait for 1 millisecond, and that should make everything run faster through to where we're breaking. Oh yeah, man, Vim is like a. I love it now. I don't know that I would give my former self the advice to like really get into Vim. Um, I don't know. Maybe I would. It's like for me, it's really natural now, and I'm not like one of the super fast people with it, and I think that's the like allure for some people is that they're going to be super fast. To be super fast at Vim, you also have to be like a really fast typer and a really fast thinker, and I am like neither of those. I'm moderately fast typer and a pretty slow thinker sometimes. Um, but what I will say is that now that I'm starting to struggle with, yeah, it does take time. Yeah, yeah, right. Um, when I'm really in the flow, it feels great, right? Like when I'm really like um got my like key bindings down and I'm able to like run my programs like with keystrokes and like get feedback really fast, like it's really great. Um yeah. Yeah, I agree with Bear entirely there. And like the code, your code isn't any different. I think the alert of me is now that like I'm struggling with some RSI things is that like I really can avoid using the um using the mouse a lot, although I'm using it right now. But I can avoid using the mouse a lot, and that helps. So if you really want to go mouse free, I think Vim is probably the way to go. Otherwise, you have to like learn a bunch of like crazy corded shortcuts that feel bad to me, and I don't think would help with RSI much. Um, but you know, to each their own. Um, and I will say that like if you look into it, I think NeoVim. I think it does. I think the problem with Emacs, they call it Emacs Pinky, is that you like often will have to hit like control meta something. So you can kind of do all the same stuff with VS Code. They have shortcuts for all of it. It's just like, uh, yeah, yeah. People who are good at those are great at them. I never got the like the corded shortcuts very well. Yeah, I agree with Bear there. But I will say that if you do try them, the whole like NeoVim ecosystem is really nice these days. It's a lot easier to sort of get into than it was. It has a lot more sort of IDE type features that make development really really nice. Um, okay, so now we're doing the yeah, okay. So 30. So this should make everything look different. Okay, so there's some blank lines like I was kind of expecting. Um, oh, oh, it's not quite right, but and there's a reason for that. Oh, that is nice. Yeah, yeah. So this is actually kind of what I expected to happen, and the problem I was expecting to solve. Although there's a little bit of funkiness in there. Um, why are the C's different? Weird. Okay. So let's escape. It's almost recognizable. That's an accomplishment. I have an up. I went in the vertical. Where would that be? Oh, okay. I think I know what you mean. Yeah, but the horizontal is a mess. Yeah. So, and the third letters vertical. Oh yeah. Okay. So let's just cargo. So that oh yeah, that's really interesting. Um, I wish I had a reference. I haven't run this thing in so long. Maybe I can get Stella on this machine and show you what it looks like. Yeah. I think part of this is like when we're switching playfields around. So it shouldn't be mirrored. Let me make sure it's not mirrored, and then I, I think basically like this should be the wild. Yeah. Yeah, I think so. Let's take a look. Actually, I'm gonna take a 5 minute break and be right back, and then we'll take a look. Been streaming for a while, but that is big progress. Is this a big end versus little endian problem? It might be um, something similar, but yes, break. I'm back. I actually have to wrap up before too long, but yeah, I'm gonna see what I can do. I think I can. I need like more space on my screen, but I think I'll be fine. I'm gonna open. I want. I don't know what I called anything back then. It's kind of a mess. Code.bmp. So I think what I should be seeing. So this makes sense to me a little bit, although one of them's 3 high, which will be higher. I think some of this is artifacts of breaking a bitmap into like pretty low res, uh, um, pretty low res picture. Although it looks like I did some weird stuff here. Let's see if I can open. Am I? Isn't that beautiful? Um, yeah. So you can see it's upside down. I wonder if I can zoom in on it all. Oh, oh no, I've really messed things up. Okay. Um, Anybody know anything about Fe? Because I can't seem to zoom in on it. So I should be seeing. I'm curious why I've got 3 down there, but I think it's okay. So basically, this on this on strip 1, I never have anything. That's just some padding. On strip 2, I have the T, like part of the T is poking out. Then on strip 3 and 4, I have like the meat of everything. So if I look at my cargo run with tic-tac-toe Ben, so I'm seeing that, and I'm seeing this like wider thing. I think that's not my error. I think that's actually what's being like the emulator's error. I think that's what's actually being fed in. Where we're getting a little bit janky is in this stuff here. And then I think these ends are pretty close to correct on this side. I'm a little bit weirded out that there's no C over there, but let's see if we can. You have to like look at it upside down. It might be right that this might be just some really ugly graphics. So, um, but there's definitely like these edges should be straight. This should not like have a little foot and stuff like that. And then why is it this for all of them? It's a good question. This looks like the right thing, and it should be probably reflect. Yeah. So why? Huh. Let me look at one more thing and make sure I'm not wrong about what I'm doing here. First line of the second row is half of an A. Uh, oh yeah, it's like almost like this is O. Oh, it's almost like this like these kind of look like T's, but I think that's by accident. I think like this middle part should be over on the side. Okay, so then what that tells me is that I've gotten my playfield logic incorrect, which is not surprising to me. Okay. Oh, weird. Okay, cool. So then what's going on there? Oh boy. Okay, so that logic's a little funky. Um, Let me make sure that I understand exactly how this is supposed to work before I go debugging it. But I think I. So this is what I was. Oh. Oh, that is weird. Okay, so I was putting these playfields together in the wrong way. That's what's going on. So I'm looking at. So for playfield 0, and it doesn't matter because playfield 0 is always 0, I was putting it order 7 to 4. And then here, this is weird. This is definitely not what I would have expected. Okay, so I should have looked at this because this is really strange. So this goes. So playfield 1 is 7 to 0, and playfield 2 is the other way around. And then if it's reflected, you just do the same thing backwards. If it's not reflected, you just do the same thing over. But the like order that these in are very strange to me. But let's see if I can recreate that and see if it makes it right. So like I have this interior bit backwards. Yeah, that makes sense. Okay. Wow. Why is it like that? I'll have to read. I just have to know that that one's like reversed. Bits 0 to 7 in playfield 2 are the opposite. Actually, okay. Okay. Well, that should be straightforward to fix then. We still may have some glitches because there's some timing stuff in there, but like I think we may be able to get rid of most of the glitches via this. So this is in TIA, and this is playfield. We're just getting playfield. So get playfield. So if it's reflected, we're reversing the bits. So here's the thing. So I need to like. So I was. It's kind of wild. Okay. So I'm going to do this and reverse the bits. So that playfield 0, make sure I have that right, will now go, because it was going from 0 to 7, so that's fine. So now it'll go from 0 to 7. Sorry, I'm like doing stuff with my fingers you guys can't see. So it'll go 0 to 7 backwards, and we just ignore this top bit. So we reverse those bits, and then we're going to shift them over by 4 more than we were before. So we're going to shift them over by 16. We're going to treat it as a full number. And then playfield 1 is the one that's like, so that's, we don't change that. But then we add playfield 2, reverse bits. And if that just works, I'll put in I don't know how to run casinos for all of us. First try? It's not. It's obviously not the first try, but oh, that's very wrong. So that's cool. That's cool. Yeah. All right, because that's 64. Sorry, I was reversing 64 bits. That's why. Can't believe this song is on the classic rock playlist. So this, I think reflected is going to be wrong because it's 64 bits. So, but we don't have to worry about that now. Let's do a to do. To do. This is wrong. It's 64 bits long. Needs to be shifted. Okay. But we're not worried about the reflected playfield right now. Did I not? It's uh it feels like it's really not far away. Let's see if I can let's see what if I can figure out what I did wrong. So, did I yeah, what is happening here? Maybe it is reflected. No, not that one. No, that wouldn't make any sense. Let me make sure. Um, intro. Don't reflect the playfield. Yeah, I'm not reflecting the playfield. So then is this wrong? Because my last one is like reversed. So playfield 0, reverse bits. I may have shifted it over too far. Did I shift it over too far? No. Let's make sure these playfields are the right kind of thing. Yeah, they're bytes. Hmm. Oh, yep. I think you called it Nomad Pixel. I did not. Yep, I accidentally reversed the middle one. And it is done. So there's a little bit of weirdness, I think. No, it actually worked. I think this is what I actually had. Yeah. Oh, huge success. I can write tic-tac-toe very poorly on what's up with the top row. What do you mean by that? Oh yeah, there's something. Oh, that's what I was telling you about. There's some I see. Yeah, there's actually some glitching going on here. The problem is, yeah, yeah. The problem is basically that there's a delay between in the on the hardware. There's a delay between when you write to a playfield and when it shows up, and this like that's really timing dependent. So what I think we're seeing here, I would really expect that C to be the same. I think some of this is just ugly. Actually, the way we can tell what's really wrong here is to let's see, sudo Stella. Oh, cool. Just really show everything. So this is the real deal. It's a very beautiful. So that's what it should look like. No, it looks right. Okay. It's just really janky. Oh, and there's like some extra stuff down here. That's fun. Yeah, this is my beautiful tic-tac-toe game, guys. So if I play, I lost. Um, yeah, so anyway, uh, so that's what it should look like. So, yeah. um, so that's yeah, I think that's probably where I'm gonna. Man, there still is timing stuff, but I guess I'm not messing with it enough. Um, yeah, that was still a toggle bit. So that was the real deal. This is mine, but it is the same. Yeah, even all the like weird glitchy stuff is the same. I just made it ugly in the first place. There's Is it exactly the same? Oh no, it might not be. Oh, we're just gonna call it the same. The one thing I was thinking of. No, it's pretty much. Yeah, yeah. It's just ugly. There's like this one little artifact at the bottom. I assume Stella's right about that, but I don't care. Um, right now. Um, yeah. So we're gonna call that a win. And I'm gonna find someplace to send us all. Also, how's it going, Togglebit? I wanted to show you before I go. Yeah, blame it on the. I mean, I made the bitmap and the thing that translated it. So it all comes down to me. It's all. Uh, so this is what I wanted to show you. This is my like debugging thing. Yeah, you caught the tail end. I've been streaming for like 3 hours. I've gotten some good stretches in. So this is like my debugging output. It's all done with cross term, and like I was like trying to figure out how to. So this is my stepwise debugging over here. It like points out which line I'm on and like what's before and after it and stuff like that. And I was like trying to figure out like, oh, okay, so I need to like go back a number of instructions and like cut it off, like based on like how big I want it to render and like and all that stuff. And I was like, man, it seems like somebody might be working on a tool that would help me uh, lay things out in the on a screen like this and deal with input and output and stuff like that. Um, so that's why I asked you. I was like, when is it? Yeah. So as soon as you tell me that it's like, I don't care if it's well documented or whatever, but as soon as you tell me you're not gonna like just write the whole thing, I will play with it and see if I can get it working. So, but I will leave that up to you to let us know when we can start messing with it. You have one big thing planned first. Cool, cool. Is anybody streaming Rust? Let's find out. I need to look at your tool where you search for it. Toggle bit at some point. We got somebody. Snake Sunday. That seems cool. All right, so we're gonna go see this guy build Snake. I think, um, in Rust. Yeah, man. Thanks for hanging out.